being still with us. And I hope you are enjoying the conference, and all the talks were very interesting, very insightful. I hope you enjoyed that one. Next, we have Jonathan Mohring and Dirk Leopold from Itemis. Jonathan and Dirk will share their expertise on managing the complexity of software-defined vehicles. They will discuss the strategy to accelerate the product development, enhance the transparency, improve vulnerability analysis, and build effective partnerships. Their insights will help us understand how to integrate security seamlessly throughout the vehicle lifecycle. Please join me in welcoming Jonathan Mohring and Dirk Leopold. Jonathan and Dirk, to you.
Great. All right, thank you, Jitendra, for that introduction, and welcome everyone to our presentation. And in general, thank you to ASRG and the entire organization for hosting this event. We've watched it grow over the past several years, and it's amazing to see the progress and the growth in attendance in this event. So it's truly great to be here. The title of this presentation today is Everything Everywhere All at Once Towards an Integrated Product Security Management for Software-Defined Vehicles. Today, we'll focus on three main things. We'll focus on some of the challenges of automotive cyber as related to SDVs. We'll focus on we'll give you some insights into the complexity of the automotive development process and the operational processes related to SDVs. And we'll talk about some proposed approaches that can help your company survive these challenges. And then we'll give you some example use cases at the end of the presentation. But before we get started, we'd like to give you a brief overview of who Itemis is and also who we are. So with that, I'll go to the next slide. If I had to sum up who Itemis is in 3 words, I'd say people, passion, and code. Our engineers are truly brilliant. We have a passion for solving customers' problems. We love working with our customers on their challenges. And we absolutely love doing this with the latest software engineering technologies. So people, passion, code. We were founded in 2003, over 20 years ago. We're headquartered in the north of Germany, close to Dortmund. We have locations in the EU and also in the US. We have a very strong automotive client base, as you can see on the slide there. One of the things that Itemis has been very successful with over the past 20 years has been developing customized solutions, customized tool chains for our clients. And many of these, as I said, are coming from the automotive industry. We also work with several automotive organizations like Automotive Security Research Group and the Auto ISAC on initiatives within the cybersecurity space. We offer products and services. On the left, you see 3 of our products: Itemis Secure, Itemis Analyze, and Itemis Create. On the right side of that Itemis circle, you see our competencies and the areas of our services. In the area of cybersecurity, PMT, or process methods and tools, model-based systems engineering, and of course, AI. Okay, with that, we'll move on to our introduction. So again, welcome everyone. My name is Jonathan Mohring. I am the head of operations in the US market for Itemis Inc. I have the pleasure of working with all of our North American customers and making sure that we can solve their problems effectively. Joining me today is before I get to Dirk, a little bit about my background. I've spent over 20 years in automotive, working in engineering IT departments, really working with a number of departments throughout automotive organizations using IT to solve engineering challenges. So it was quite an interesting 20 years I was able to experience both in the US and in Europe. So joining me today is Dirk Leopold, and I'll hand it over to Dirk to introduce himself, and Dirk will take you through the first half of our presentation. So over to you, Dirk.
Thanks, Jonathan. Thanks, Jonathan. Yeah, I don't have 20 years in automotive, but I have 25 years in software, and about half of that automotive related. And interestingly, already my first job 25 years ago was security related, but not in automotive, but in internet banking. So security kept haunting me throughout my business career. And I'm actually a trained mechanical engineer and business administration. So I can also appreciate all the mechanical engineering aspects of automotive. And I think that's yeah, it's a very gives me the unique opportunity to look at the problem from maybe different angles. I started the automotive cybersecurity activities at Itemis about 8 years ago, and I was also in the lucky position to witness the initial months of ASRG when it was still like only one group, and it was in Stuttgart, and we met like with 10, 12 people somewhere in, I would call them hacker dens, yeah. It's amazing to see how far ASRG got in the last couple of years, even throughout Corona. Yeah, the growth was amazing. Yeah, and I'm glad to be here now. So maybe to the next slide, Jonathan. So just to set up the talk, I just want to clear a couple of things, because it's automotive cybersecurity, and for some people maybe it feels like, oh, it's nothing I really want to do, but I have to do it because there's UNR 155 and there's ISO SA 21434, and we have to do this because it's compliance. Yeah, but I think and that's specifically true for all the ASRG members that I know. I think it's for us, it's mostly about the cybersecurity core. So we really want to create a secure, safe and secure environment, in that case for drivers and for road users. So Jonathan, if you go to the next slide, and that's something that I learned in my first job already. So before that, I didn't have much to do like during university with security. What is security? And I think in essence, we all know this is confidentiality, integrity, and availability. And back then, CIA, the abbreviation, always helped me to remember this. Yeah, so it's confidentiality, integrity, availability. There's a lot of other aspects related to this, but I think in our core, we want to achieve secure vehicles and not predominantly compliance. Yeah. And if you go to the next slide, also, I think we are aware that it's not nice to have security, but it's really something essential to the users. I mean, we don't want accidents happening because of security breaches, but I think it's also important for the companies that we work for. And that's because, again, next slide, security or the breaching security is a viable business model. So you can actually make money. You can steal cars, you can blackmail OEM and suppliers. And even if you look at let's say at our customers, yeah, those that buy or lease vehicles, I mean, they might be tempted to hack a car to get paid features for free. And because there's a business model, we just have to assume that this is not going to go away. Yeah, it's not going to go away, and it can potentially harm the vehicle users, and it can severely harm the companies that we work for. Yeah, so there is a high motivation way beyond compliance that we get this done in an efficient and effective way. Which brings me to the last point. Some of you might say, yeah, but there's AI now, and I don't think I need to deal with this because somehow magically AI is gonna solve all my security problems. I don't think this is the case. Yeah. One is with AI systems, you have something else that you need to protect, and that might be very sensitive to external manipulation leading to effects that you don't want. So it's one more problem that you have to deal with. And also, it's not the magic bullet. Yeah, if you go to the next slide, Jonathan, there's a number of reasons for it. Yeah, you need data to train the AI, and sometimes problems are new, and because it's new, you don't have the data, or the nature of the work is such that you don't have 10,000 data sets. I mean, we are very busy with doing Tara work. Yeah, how many Taras do you have? I think if you have 500 Taras in your organization, that's already a large number, and that number might not be large enough to really do a proper training for an LLM. The other thing is, if you make decisions, like deciding that the risk level is so high that you need to act, maybe even recall vehicles, you wouldn't want to decide this based on a statement by an AI that it's risky. You want to know why. You want numbers. You want this explained. Yeah, and explainability is still tricky with AI. Because what happens in those neural networks, you can't look at it and understand what the AI actually does. Yeah, so explainability is a problem. Plus, sometimes you get results that are not even based on the training data, but they are so-called hallucinations. AI is so good today, they can even invent sources. Yeah, you can ask the AI to basically give you the sources, like the names of the studies and the authors, and the AI comes up with names of studies and authors, and then later you find out they don't even exist. Yeah, AI is so great, but it's not the silver bullet for security. That's why I think we have to look at this with some engineering eyes. Yeah? And that's why now it's gonna get a bit more engineering. Yeah, I want to talk about development complexity and then operational complexity. Some of you might be familiar with this V model. So basically, it deconstructs the process of developing a vehicle. So you start in the top left corner with product requirements, and then you go down system design, specification, and so on. And then on the right-hand side, you have the test aspects, and you end up with systems acceptance. And this can be in parts agile. So I indicated these iterations. So there are areas where you have something like agile work aspects, but as a whole, this is pretty much waterfall. And you see these milestones on top. Yeah, so there are certain milestones that you reach, and to get from the far left to the far right takes you, depending on whether it's a completely new vehicle or whether it's just a facelift, let's say 2 to 4 years. Yeah, just have to keep that in mind. That overall process is like 2 to 4 years, and then you start with production, and the operational phase begins. If you look at how this is achieved, we can look at the various tools that you find there. Jonathan can show this on the next slide. These are just examples. So what we see on the client side, OEMs, tier 1, tier 2s, they have all kinds of tools that they use to produce these artifacts that you need in those various stages. These are examples, and you find all kinds of mixes. Yeah, very important are the 3 in the middle. It's basically Microsoft Office with Word, PowerPoint, and Excel. So major parts of your vehicles might be designed in PowerPoint and then calculated with Excel, and it still works, which I always find amazing. But you also have specialized tools. Just a few examples here again. Yeah, there's IBM DOS for requirements management. You also find Itemis there. Yeah, you might do your Tara with an Itemis tool. And on the right-hand side, yeah, just some examples. So that's not supposed to be complete or anything. These are just colorful examples. But you can tell it's kind of complex because you have different tools, and somehow everything has to fit together after 4 years, even though those tools are not really interlinked. So within let's say even within the Microsoft sphere of tools, yeah, just because you do something in Excel, PowerPoint doesn't know about it. Yeah, so linking this is a lot of manual extra effort. If we then look at the operational side of things, even though the activities are named something else, yeah, you have like monitoring, so you might look at data that is produced by the vehicle during operations that you might want to look at. You still do maybe testing, then you have the whole area of vulnerability management. We get to an example for that later. And you also have to update your requirements management. So it's called something else, but in its core, it's similar activities to what you do during development, but you don't have that much time for it. Yeah, you don't have that much time for it. So keep that in mind. So if you compare those two aspects now, you will see they're different in timing. So now let's get to the software aspect of things. Yeah, so 20, 30 years ago, there wasn't so much software in vehicles, so a lot of it was mechanical. It also didn't have as many interfaces, and you didn't really need to update software of your vehicle. The only thing maybe starting 15 years ago that you had to update on a regular basis was the map information of your navigation system, and then you put in your SD card and it takes like an hour, and then you have new maps. Those days are gone. Yeah. So what you see here is basically a study that was done by Research China. So they looked at 1.5 years of software updates of vehicles in China, and they basically counted how often there was an over-the-air update, yeah, of software. And you see on top here, not really surprising, is Tesla with 45 over-the-air updates within 1 year. So that's almost one update per week. Yeah. Then if you go all the way down, you have like, let's look at the last three. So you have an OEM from the US, you have an OEM from Germany, and you have an OEM from Japan. They don't update or didn't update their vehicles as often. So the question is, why is that? Is that because the Tesla software is so buggy that they have to like ship bug fixes every week? I don't think so. I don't think so. And I don't drive a Tesla, but I kind of looked at a lot of, let's say, Tesla user chats and the Tesla community. And what I noticed was they get real updates. Yeah, so Tesla users get real functional updates throughout the lifetime of the vehicles, functions that were not there when they bought the vehicle. Are then magically after an overnight update there. So you might be able to open your boot, or you might have a better reverse parking assistance. So real useful actual functions, not just bug fixes. And that has something to do with the fact that we entered the age of software-defined vehicles. So what does that mean? Functions are predominantly defined by software and not so much by hardware. Not so much by hardware, please don't get me wrong. Of course, if you have like matrix LED lights, of course you need the hardware of the light. But the way you design a function around that hardware is then predominantly software. Yeah. So, and especially a lot of the interesting stuff, and that's also the infotainment system, etc. That's all software. That's all software. So we are in the age of software-defined vehicles, and that's why it becomes more and more important to be able to update software. And the question is now: is Tesla the exception, or is it going to be the rule? So, and that kind of got me thinking, yeah, and maybe also my 25 years in software came in handy here. There's a concept in software development that is the minimum viable product. So the idea is that if I ship software, I don't have to ship 100% product. I could ship a 70% product, then get some feedback, and then only decide what is the next 10%, and then what is the next 10%, what is the next 5%, and this goes on throughout the life cycle of the software product. The advantages are obvious. So I can ship early and I can get feedback early. I can also start making money early. Yeah? So I have a shorter time to market. So what happens if you apply the idea of a minimum viable product to a vehicle? Yeah, then you could see the start of production, which is a very important date in the life cycle of every vehicle, not as the final product, but that's the intermediate product. That's maybe 65 or 75% of the product. And I know that over the next 3 or 4 years, I'm going to ship more functionality. And if you see that, then if you go to the next slide, yeah, the challenge becomes pretty obvious. So in development, I have 2 to 4 years to get everything right, even if I have like multiple different software that I use to create artifacts, to make it fit after those 4 years and to be good enough to ship. But if I then treat my operational side as a continuation of the development, then it becomes obvious that for basically the whole set of tasks that I used to have like 4 years for, I now have 1 to 2 weeks for. And if you look at the factor, that there's nothing I can reach by just becoming a little bit more efficient. So I cannot get from 4 years to 2 weeks with a similar, let's say, level of quality, safety, security by just speeding up things. I need to do some things in a very different way. And this improvement by factor 50 or 100, that's what we want to share some thoughts about, how that is even like remotely possible. And I hope that Jonathan can share some of our thoughts here.
Great. Thanks, Dirk. So yeah, so Dirk told us a lot about the challenges, right, and the development complexity that is inherent in our automotive development process. And it gets more complex with SDVs. So let's shift our focus now to solutions. So we work with many customers, obviously, in the automotive sector. What have our customers, automotive customers, told us that they need moving forward? We have a relatively short list, laundry list of things that they want. The one thing that we hear quite often is we want a solution for end-to-end risk assessment. We want a solution that covers development and the operations phase, as Dirk focused on. We want a solution that allows for frequent iterations, a solution that produces updated risk results close to real time. So that's fast. And also a solution that allows for a high level of collaboration, of integration, and of course, automation. So that's quite a list of requirements, and to us, that sounds more like a platform of solutions. In fact, it sounds like a product security management platform. So let's look at some fundamental technologies that we feel should be part of such a platform in the next slides. At its core, such a platform needs what's called a semantic model of the engineering space. My colleagues at Itemis often talk about semantic models and how powerful they are. And my first question upon hearing this was, well, what's a semantic model? Can you explain it? So I'll give you a relatively simple example. We all work with types of requirements. And these requirements are contained within various types of documents and systems. We could argue that customer requirements are semantically different than technical requirements. Both types of requirements are related to each other, but they're also related to other development artifacts, such as design documents and tests. These semantic types of development artifacts and the links between them are numerous, a ton of them, and it's very complex, that network of links. A semantic model contains both these artifact types, and it contains the links or the relationships between these different elements. Maybe the more important question, what can we do with it then once we have this semantic model in place? And simply put, a semantic layer allows an engineering organization to turn raw data into information. And that transformation allows three things to happen. One, it allows data to be organized in a way that we as humans understand it. Two, it provides an ideal basis for automation. So you think process automation, workflow automation, impact analyses for transparency, and also reporting automation. And three, it creates an ideal foundation for AI. So AI works better, a lot better with structured and semantically similar data. So let's look at a use case focused on this platform approach. This use case is focused on integrated Tara and vulnerability management. And I can give you a concrete question that our customers have asked us. And the question is, show me what Taras are affected by a new vulnerability related to a specific SBOM, and help me update my risk. So how would we approach this? Simply put, we know the SBOM information about the software components and their related vulnerabilities. And we would use a semantic layer to model and connect the Tara artifacts with the relevant artifacts from the SBOM. Such a connection via the semantic layer, it also works with other data sources as well, not just with the SBOMs. So Tara can be connected to various sources of information. So this sounds relatively simple until we actually look in detail what it means. It becomes very complicated if we want to understand the wider impact analysis throughout that V model. So we not only want to understand the impact to the security domain, but also the impacted engineering artifacts. What do we see here? We see it's a long way to go from CVEs to risk. We see we traverse many security and domain relevant artifacts. We go through various levels from system to detail, and we go through various processes from requirements to test. We also see that there can be information breaks in a typical OEM toolchain at various points along this process. The good news is that this rather long and stony process can be made faster by having the appropriate tooling put in place. And so the key question here, how do we survive this everything, everywhere, all at once moment? And our perspective on that is by looking at CIA in a new way. And these ways are by collaborating, by building solutions together with our customers and understanding their specific requirements, by integrating. So there are many, we know, great solutions on the market for cybersecurity, but no one single vendor can provide all these solutions. So let's form partnerships and let's integrate the best-in-class solutions together for our customers. And the third point, by automating. So whether it's knowledge graphs, model-based approaches, AI, or other methods, let's minimize the manual effort and automate as much as we can so we can react very quickly, close to real time, to cyber threats as quickly as possible. All right, with an eye on the time, I think we're close to time now. So this concludes our presentation. We sincerely hope we were able to offer you some insights into the very complex world of product risk management for SDVs. Should you have any questions or need more information, please do not hesitate to get in contact with myself or with Dirk. We also have colleagues in our virtual booth at the moment. So if any of you would like to reach out to us after this presentation, please feel free to do so. We'd love to hear from you. Thank you, everyone, for your time. And with that, I would hand it back over to our event host.
Thank you, Jonathan and Dirk. It was really insightful. And with that, we are almost with the time, but would like to take 2 questions, which we have it in Q&A session, and those been upvoted as well. I will just bring one by one both to the stage. there is a hype in the industry to use Agile. How can we both be Agile yet follow the V model efficiently, especially considering the need to continuously maintain the work products across the vast number of customers' specific variants?
Jonathan, you wanna give it a try, or should
I'm
I?
thinking, I mean, my inherent answer is that you have to have the, both models are followed, correct? Both
Yeah.
models have their relevancy, correct? And you need to be able to, marry those two approaches together. Neither one of those approaches is going to go away. So you need the right solutions and tooling in place, I think, to help you manage those different approaches to more the software centric aspects, and then more the hardware centric aspects. That'd be my general response. Dirk, do you have anything to add to that?
Yeah, I also, I don't think it's a contradiction, but I think automotive has a special setting with compliance and with documentation, and so it's not just an application that I can develop in a trial and error way. Yeah, so there's a certain quality level that I need in artifacts, and I think I can still be agile, let's say within certain subdomains, for example, improving the infotainment system. I think the teams working on the infotainment system, they can try out ideas, but they are in a frame where they have to stick to some rules, and where they also have to be able to come up with certain set of documentation before they take anything productive. So I don't think it's a contradiction, but I think what we suggested here, to get more tracing and understand more dependencies and have a way of automating, for example, also documentation, is the right combination to go. Yeah, so it's a good question, and maybe we could also include the aspect of how to get agile in the presentation in the next round. Yeah, so thanks for the question.
Thank you. And one last question, which we will take it, is producing a minimum viable product with the promise that we will deliver more features in future. Will the customer accept this for a vehicle is kind high investment?
I would phrase it's a great question. I would try to phrase it in a slightly different way. Would you accept to buy a vehicle that costs 50,000, 80,000, or 100,000 euros or US dollars? Would you accept a vehicle that doesn't improve after you bought it? And I think that's the more interesting question. What I don't want to buy is a vehicle that is not done. I mean, I've been a like gamer for all of my life. Nothing is more frustrating than trying to play a game that is basically not finished. Yeah, and you just deal with bugs the whole time, and then you chuck the game in the corner. Of course, we don't want to chuck a car in the corner. So it has to feel like it's a well-rounded, high-quality solution to start with. Yeah, so I'm not proposing to basically sell in software that they call it banana software. Yeah, so it ripens while it's at the customer. That's not the suggestion, but I think there is and Tesla owners already experience this. There will be an expectation that if I buy something super expensive, that this is not outdated half a year after I bought it. Yeah, and I think this is the switch that we're going to see. And if you have no answer to how do I make sure that I still enjoy my car in year 3 the same way I enjoyed it on day 1, I think part of the answer is come up with new things, surprise your client, yeah, deliver something on top of something that's already good.
Thank you, Derek. I think we already ran out of the time, and with audience, my request is Itemis team is already available in lounge area, and Jonathan and Dirk will be available as well. So please reach out to them, have your all queries and questions answered. With that, we would like to close the session, and with the thank you note to the Jonathan and Dirk. Thank you so much for your time and wonderful presentation. A lot of insights we had it, and thank you a lot for your efforts. Have a good time, everyone. Enjoy the conference.
Thanks
Thank you.
for the opportunity.